equals some t. If we apply secant to both sides, the secant inverse cancels out. So that's secant of t is equal to 2 over square root of 3. You kind of separate that a little bit. So if that's true, then that also means the reciprocal of secant, which is cosine of t, is equal to the reciprocal of 2 over square root of 3, which is square root of 3 over 2, which is equal to power 6. Okay. Does that make sense?
Yeah, so the reciprocal of cosecant would be sine.
Yep, the reciprocal of cosecant is sine.
And then the tangent and cotangent would
Yep.
be flipped.
Yep, then those two just flip.
Okay, I'm just trying to remember.
Oh, I know it's it's been a minute.
Yeah, definitely.
All right. Any questions on that one? All right.
All that
All right. You're still writing. Okay. Okay, and the final thing we're going to go over, area between two curves. Okay, so the last thing we go over here will be the first thing you go over in Calc 2. So they will actually cover this on the very first day. So what if we let f of x and g of x represent two continuous functions? Where we know that f of x is greater than or equal to g of x for that entire interval. So it's over the interval from a to b. Okay. So the region between those two graphs, or those two functions, so it's bounded above by f of x and below by g of x, has the area is equal to the integral from a to b of f of x minus g of x with respect to x. Okay, so if we wanted to look at that as far as a graph, let's say you have some function, this is f of x, and this is some function g of x. And we're going from a to b. Okay, so every point between there, f of x is bigger than g of x. So we're just going to mark that off. So we want to know the area of this region here. So we'll just shade that in. Okay. So what we're going to do is we're going to find the integral of the area from f of x. But remember, f of x, when we find that entire area, it goes from that function all the way to the x-axis. So what we're doing is we're taking the integral of that function, minusing the, is that a word? Subtracting, that's probably a little better. Subtracting the integral from g of x to the x-axis. So this down here gets subtracted. So all we have is the area between those two curves. Now, if g of x happen to be bigger than f of x, then the area is going to equal the integral from a to b of g of x minus f of x with respect to x. So just because they give you an f of x is this and g of x is that, it doesn't mean that f of x is always going to be the first one.
So it all depends on
Which one
what they,
is larger?
yeah.
Yep, which one is larger?
So where f of x is larger, g of x or g of x is larger.
Yep, so whichever one's larger will be the first one.
So how would we find the area? So what is the shaded area below the R?
Oh, that's the area you're subtracting. So you're getting your f of x minus what's below g of x. Because
Oh,
remember,
okay.
this is the area of g of x.
So what you're trying to find is R, which is
Right.
area in
Yeah.
between.
Which is in between, so therefore we would have to subtract the, because.
Oh, actually, I should have put the region R. Sorry about that. That probably.
Now, is that saying when you take the integral of f of x separately from, and then subtract it from a separate integral of g of x?
Oh, no, you can just do them all together.
Okay.
Yep, so once you subtract the two, then you integrate right there. I mean, if you wanted to do them separately, you could. It's just more work.
But wouldn't that be, I mean, instead of r, wouldn't that be a? Because you have an a listed as that? I mean, isn't a and r the same thing right there?
It
Or do
is.
you have it right?
But the only reason I use R instead of A is because you have two areas. So you have
Right.
this area and that area. So to
Right.
kind of distinguish between the two, I use R to represent region.
Well, in this equation, a and r essentially are the same thing?
Oh, yeah.
Okay.
Essentially the same thing.
I just wanted to make
Yeah.
sure.
Yeah.
I didn't know if we were gonna end up doing that and then doing another equation.
Oh, no. Yeah, I mean, we just use R to represent
Yep.
between the two. That's all.
Okay.
But then with the equation, it's just subtracting.
Yep.
All right, everyone's still writing. Looks like everyone's done. Okay, so let's say, for example, if we want to calculate the area in square units bounded by g of x equals 4x plus 5 and f of x equals 5x plus 8 over the interval -14 to -8. Oh, let me clean up that -14 a little bit.
That doesn't say which one's bigger.
Nope, it doesn't say which one's bigger. That one you have to actually figure out. So here, so to calculate which function is greater, find where they intersect, and pick a test value. That's in the interval. To see which is greater. Actually in the interval. Okay. Now this first part of the first step, you really don't have to do here because they'll give you the interval. But when you go to Calc 2, you have some problems where they won't give you the interval. So that's where you have to find out exactly where they intersect and then find that interval yourself. So we're really just going over that before you have to use it. Okay. So we want to find out where they intersect. We just make 4x plus 5 equals 5x plus 8. So if we subtract 4x from both sides and subtract 8 from both sides, we end up with x equals -3. Okay. So we have where x equals -3. So we know that those two, they're linear, so they only intersect at one point. They intersect at x equals -3. So now we pick a test point between those two. Okay, so we can pick, let's say, x equals, if they intersect, we'll pick a point to the left of it. We'll say x equals -4. Yeah, better yet, -10. Since -4 is actually not in the interval. So that means f of -10 is 5 times -10 plus 8. So you have -50 plus 8, so it'd be -42. And g of -10 is equal to 4 times -10 plus 5. So you have -40 plus 5 is -35. Okay. So g of x is actually bigger than f of x. Actually, let me put since g of -10 is greater than f of -10. Move that over a little bit. Okay. So we know since g of x is greater than or equal to f of x, the g of x will go first.
You won't have any questions where, when you find where they intersect, will be within the interval?
It won't be, but you will run into it in the next class. Just not here because there's just kind of an introduction here.
All right.
But you'll have some in Calc 2
Then
where,
there will be a partially
yeah.
larger on one side and partially.
Yep, so you may have g of x minus f of x
And then it
from one half, and then f of x minus g of x for the other half.
Okay.
Yep, so we won't have that here, but you will run across it.
So do you always go to one side or the other, or you just pick either side? Because that's where the intersect
Mm-hmm.
is -3. You just pick, like, because you pick -10, but
Mhm.
does it matter whether you go like -10 or actual 10?
Oh, I just picked -10 because it's in that interval there.
Because it's in that interval?
Yes.
Okay.
Yep, so if you can pick a point in there, because it's linear, so if it's f of x is above g of x in this point, then it's going to be over the whole thing.
Okay.
That makes sense?
Yeah, so even though x is -3 at the
Mhm.
intersect, that just means that it intersects
On the-
beyond our interval that we're
Exactly.
looking for.
Yep, exactly.
It pretty
Yeah.
much means that at that point, x equals -3, f of x or g of x becomes larger than the other.
Yep, that's it. That's the only time when they're the exact same value. All right, so once we find that out, we just figure out our area. So it's the integral from a to b. So we know g of x goes first, so it's g of x minus f of x. Which is equal to the interval from -14 to -8 of g of x. So you have 4x plus 5 minus f of x, so 5x plus 8 with respect to x. Okay, so if we distribute that negative here, we'll have negative, actually we'll just go ahead and do that right up underneath so we won't have to keep rewriting all the integrals. So you have 4x plus 5, about to write 5x. 4x plus 5 minus 5x minus 8. Okay, so you have the integral from negative 14 to negative 8. You have 4x minus 5x is just negative x. And 5 minus 8 is minus 3.
Still dx?
Oh, yep, still dx. Okay. Now once we integrate, then the dx disappears. Okay, so we have the integral of negative x, which is just negative x squared over 2, minus 3x from negative 14 to negative 8. Okay. It's definite, so we don't need the plus c.
You can technically factor out that negative just to make your life easier, right? To negative 1.
Oh yeah, you could. So if you want to make that negative 1 times x squared over 2 plus 3x, you could have done that too. Okay, so first we want to plug in the negative 8. That's negative 8 squared, negative 8 squared over 2 minus 3 times negative 8 minus, you plug in the negative 14, negative 14 squared over 2 minus 3 times negative 14. And that's going to equal 8 squared is 64. 64 divided by 2 is 32. So negative 32 plus 24 minus 14 squared divided by 2 is 98. So negative 98 plus 42. And that ends up becoming 48 units, since we're running out of space. Well, 48 square units, since we're talking about area. Oh, move that up a little bit. Okay. So any questions on that one? All right. Leave that up for a few more seconds.
So if you had the constant, if you had a constant on there,
Mm-hmm.
and I'm sure you probably end up doing these next, I'm not sure,
Mm-hmm.
but you can factor out the constant before you integrate, right?
Oh yeah, if you wanted to factor that out, you could have.
Okay.
So if you wanted to have it negative 1 times the integral of x plus 3, you could have. All right, anyone's still writing? All right. So for our next example, consider the region bounded by f of x equals negative x squared plus 11x minus 3,